Hello and welcome to part 2 of this MVA course focused on virtualization in Windows Server 2012 R2. My name is Matt McSpirit and I'm one of our technical product managers in the Windows Server and System Center team. And in part 1 we took an extensive look at some of the key scalability, performance and density capabilities within Windows Server 2012 R2, from dynamic memory to virtual NUMA to virtual RSS and a whole host of other key capabilities. So if you missed that part, go back and watch it. There's a load of cool information in there that you'll find very, very useful. But in this part 2, we're going to actually start to delve into some of the security and multi-tenancy capabilities within Windows Server 2012 R2 and how they provide a fantastic foundation for our enterprises, our partners, our customers, our hosting providers to build the infrastructure they need to run in a secure and isolated way. Now, when we think about security and multi-tenancy, when we think about our virtualized data centers, they're becoming more and more popular and practical every single day. And organizations and hosting providers in particular have begun offering things like infrastructure as a service, which provides a very flexible, virtualized infrastructure to their customers. Think about server instances on demand, for instance. And because of this trend, IT organizations, enterprises, and hosting providers, they must offer that enhanced level of security and isolation for those different customers or business units potentially that they are virtualizing. Now, if you think about a service provider hosting 2 companies, that IT admin must help ensure that each of those companies is private, is isolated and secure, but still can communicate out with the relevant business systems, out to the web, the internet, the internal network, whatever it may be. Now, before Windows Server 2012 and R2, that was tricky, that was difficult. There wasn't as many configuration options that enabled that granular isolation and secure control. But with 2012 and now in 2012 R2, the configuration options, the granular configuration capabilities you have and the sheer number of features within the platform to enable those kind of scenarios has really gone through the roof. So we can provide the best platform for isolation, for optimal configuration, and really with all in-the-box capabilities. And we're going to explore a number of those now. But what are some of the challenges and considerations that customers are making when they think about security and multi-tenancy? What's important? What do they want? Well, they're wanting those workloads, those important mission-critical workloads, the big workloads that we talked about in part 1. They need to have the highest levels of security, isolation, but they need to be granular in the way they're controlled. So it needs to be easy to control, it needs to be as granular as people want to go, either through interfaces or through PowerShell, through scripting. And it needs to integrate again, and we saw this as a key theme in part 1, with existing software and hardware investments. From a networking, from a storage perspective, how are they all coming together? If a customer has got a compliancy need, how can we meet that? There's a lot of organizations out there that have very strict requirements for encryption. Everything has to be encrypted. Every piece of data that's within the infrastructure has to be encrypted. How is that done in a virtualized environment? Third-party software, is there something in the box? Do I need system management tools to do that? Don't worry, we'll take a look. We'll look at some of those capabilities within Windows Server 2012 R2. And what if I want to customize it? I'm a customer, I've got a very savvy dev house, I've got a partner that I work with who's an ISV, a software vendor who's building extensions. Can they plug in? Can they extend the platform to provide a specific solution for customer X, customer Y, customer Z? Yes, with Windows Server 2012 and R2, absolutely, and we'll look at some of the ways that they can do that. But how are we delivering it fundamentally at a high level within Windows Server 2012 R2? When we think about isolation and security, we're thinking about VLANs and PVLANs, private VLANs. We're thinking about ACLing, virtual port ACLing, to control which VMs can communicate with which VMs. We're thinking about monitoring ports, so we can not only monitor but mirror traffic between virtual machines' ports to ensure that if we need to sniff and interrogate that traffic and understand just what is going on between a couple of virtual machines, that we can do that effectively. Previous versions of Hyper-V in 2008 R2, that was very, very difficult, if not impossible. In 2012 and 2012 R2, simplified, in the box, those capabilities are exposed for you to consume and for partners to consume with their value-add solutions on top. And a lot of this is unlocked by this innovation known as the Hyper-V Extensible switch. The Hyper-V Extensible switch, as we'll see, is a new release of the network switch, the Hyper-V vSwitch, that you bind to the physical NIC that allows VMs to communicate out onto the infrastructure. That vSwitch that was in 2008 R2 has been transformed into this much more granular, configurable, extensible network switch that allows you to define more policy in the box and allows partners to plug in, and we'll see a couple of examples of those as well. When we think about some of those examples of granular security mechanisms, we think about DHCP and router guard that enable us to protect against those kind of rogue attacks, those kind of malicious instances even within our own IT environment. If somebody stands up a rogue DHCP server, that can cause havoc within the environment. So we need to control against those kind of situations. And when that encryption scenario I talked about before, from a compliancy perspective, in the box with BitLocker drive encryption, which people assume it's just for my laptop, surely. You know, I don't take my server through with me to the airport, I don't leave it in the security tray and walk away. That doesn't happen. Not everyone has servers in secure data centers. People have them in retail stores, they have them in places where they are accessible to criminals. BitLocker drive encryption allows me to encrypt those kind of environments, and we'll look at what that means for different scenarios and virtual machines very shortly. But it's not just about laptops and tablets. And then we think about extending and the ecosystem that Windows Server has always provided out of the box for customers and partners to build on top of. But what about this specific multi-tenancy and this extensible switch layer? What kind of things are people doing there? We'll take a look at some of those as well. So I want to drill in initially into that network switch because it forms the foundation of VM communication. It's the way that VMs communicate out to the web. They communicate out through the virtual network adapter that's bound to the virtual switch. And we see a good representation of that in the graphic. We see a couple of Hyper-V, we see a Hyper-V host with a couple of virtual machines. Each of those VMs has a single virtual network adapter, and those VNICs, as I'll call them, are attached to the single Hyper-V extensible switch in this case, and that is bound to the physical network adapter, which is bound to a physical switch, a regular network switch, which allows the rest of the network to communicate. So if virtual machine 1 on the left-hand side wants to communicate with one of the servers in that rack on the bottom right, it's going to communicate out through the extensible switch, out through the physical NIC, and out through the physical switch itself, and onto the regular network. Now, the Hyper-V extensible switch is a layer 2 network switch for VM communication and connectivity. It runs in the management OS of the host, so it's something that's bound to the physical network adapter on that host, and it exists in Windows Server Hyper-V, and if you're developing extensions, which we'll look at shortly, you may want to develop on Windows Client Hyper-V. Remember, Hyper-V has existed in Windows Client since Windows 8, and it's also in Windows 8.1 as well. It's managed programmatically, it's extensible as we'll see, and that's how, as I talked about earlier, VMs communicate out of that host. They use an extensible virtual switch in Windows Server 2012. And unlike competitors in this virtualization space, it's not a choice. The extensible switch is the switch. Whether you choose to extend it or not is up to you, but that is the switch. It's completely open, it's extended through regular, as we'll see, Windows interfaces, and it's accessible for all to extend. There's no specific bar, there's no specific SKU of Windows Server that you need to have in order to use this extensible switch. So it's there for all to consume. Remember we talked about in part 1 when we were talking about SRIOV, single root IO virtualization. This is a scenario where a physical NIC that's got SRIOV capability plugs its virtual function into the virtual machine. That bypasses the use of this extensible switch. So the virtual machine is connected directly to the physical NIC and doesn't use the Hyper-V extensible switch and the processing and the capability that exposes. That's something to be aware of when you're deploying. So yes, you can get increased performance, lower latency, lower CPU utilization if you're using SRIOV, if you've got the appropriate hardware, but you lose some of the benefits that come with the Hyper-V extensible switch. Some of the benefits we'll look at now. When we think about the extensible switch as well, one of the capabilities that it provides is this protection against ARP and neighbor discovery poisoning, which is very common in network environments. So it can protect against spoofing. So malicious attacks that aim to impersonate different resources on the network. So we want to protect against those. We want to stop the rogue DHCP servers and rogue routers causing problems on the network. So there are specific settings exposed in the UI of Hyper-V Manager within the Hyper-V host management infrastructure that enable me to protect against those and turn on certain security capabilities. Virtual port ACLs allow me to actually implement a control mechanism that defines what can communicate with what in the environment. So for instance, I can isolate networks and meter traffic for a particular virtual port on the Hyper-V extensible switch. I can meter the IP addresses. We looked at resource metering in the earlier part 1, and I can control what can communicate with what. So two VMs, yes, they can communicate with one another, but only over certain ports, for instance. So I can control at a source or destination network address and permit or deny a particular action. So it gives me some granularity. This isn't controlled through the GUI. This is something I would define through PowerShell, but it's very easy, very well documented on TechNet as well. When we think about a virtual machine that maybe is the endpoint for lots of VLANs, rather than use lots of VNICs, each with our VLAN associated, and terminate there, I can configure virtual network adapters to trunk VLANs, so VLAN trunking to a VM. That's not exposed through the GUI, but it's something I can easily configure through PowerShell as well. But then we also, as I said earlier, all of this is extensible and manageable through PowerShell. I can monitor traffic through the GUI, so I can turn on source and destination mirroring and monitoring. So I can say that VM A, it needs to ferry its traffic across to VM B, which has got a network sniffing tool within it, so it can analyze that traffic more effectively. So that's very useful in certain scenarios where I want to actually see what's going on the network. Maybe there's some suspicious activity that I want to track. But we've also got this capability of PVLANs. I mentioned VLANs a minute ago as a way of segregating traffic within the network. So each packet is tagged with a VLAN ID, and the corresponding VM would need that particular VLAN ID on its virtual network adapter to successfully receive that traffic that's come in from the outside world. Now, VLANs are typically quite difficult to scale in large environments because you can have a lot of VLANs, and not all switches support huge numbers. The actual technical limit of VLANs is 4,095. Not all switches support more than 1,000. And if you're running a lot of VLANs, that can be complex. And we'll talk later about network virtualization that can solve some of those networking challenges. But if you've got VLANs implemented, but you need more granularity within the VLANs, that's where PVLANs can help. And PVLANs are kind of like a level, as I said, of isolation within the VLAN. So they enable me to create an infrastructure, almost like a secondary VLAN. So you'll see here I've got an environment where I've got a number of different guest OSs, and you'll see here that these two VMs, they can communicate on certain networks. So for instance, the primary VLAN ID is 2, the secondary ID VLANs are 4 and 5 in this environment. So these two guest OSs, they can communicate on an isolated network, but they can't communicate any further in this case. When we start to introduce more virtual machines to this environment, and they're on what are known as community networks. So community networks are slightly different in their configuration. These ports on the same VLAN ID can exchange packets with each other at layer 2. And they can also talk to promiscuous ports, but they can't talk to isolated ports. So we're struggling to talk to blue VMs from the yellow in certain scenarios. But if we move on and introduce a grey VM that's configured with promiscuous mode, you'll see that that can pretty much talk to anything. Because it's configured, they can exchange packets with any other port on the same primary VLAN ID. And the secondary VLAN ID makes no difference. So they're the three types of port types in the private VLANs or PVLANs. Isolated, which can't exchange packets with each other at layer 2. They can only talk to promiscuous ports. Community, in yellow, they can talk to VMs on the same VLAN ID at layer 2, and promiscuous, they can't talk to isolated. And finally, promiscuous in grey, they can exchange packets with any other port. So they're pretty much open from that perspective. This allows me to create groups of VMs that can exchange packets with one another in a more isolated way. Remember, within the same VLAN. So that's something very useful there if you do want to define it a very granular way. This is again exposed through PowerShell, so not through the GUI within Hyper-V Manager. We talked before about extending through partners. Now this Hyper-V extensible switch is a layer 2 virtual switch that, as I said, provides that programmatical management and extensibility to connect virtual machines to the physical network. And it's an open platform. Anybody can start to plug in through standard Windows API frameworks. And the reliability of these, because it's a standard framework, you can build in a known way. And it's backed by the Windows Hardware Quality Labs certification program as well. So you know you're getting tested, verified code when you're buying solutions from partners who've developed extensions to the actual extensible switch. You can manage these extensions through PowerShell or through WMI, and in many cases through the Hyper-V Manager user interface as well. And there's a couple of different areas that we need to investigate. The diagram now shows the architecture of the extensible switch, and you'll see within the parent partition, within the extensible switch, you've got a number of capture, filtering, and forwarding extensions. So they're the different types of extensions that people can write. So we'll look at a few of the examples in a few minutes, but they can write NDIS filter drivers, WFP callout drivers, there's ingress filtering, destination lookup forwarding, egress filtering, lots of different options for people to plug in to the virtual switch. The beauty of these extensions is they're not exclusive in the sense that if I use one, I can't use any others. That's not the case. With the Hyper-V extensible switch, I can plug in extensions at different layers, so I can combine multiple extensions to build the solution that I'm looking for. So it's very, very useful and flexible in order for me to actually utilize the different solutions to make the solution exactly how I need it for my environment. And again, you'll learn more about the intricacies of the extensible switch in the MVA course for the networking in Windows Server 2012 R2. When we look at some of the key vendors that have started to extend the platform, we're thinking about vendors like Cisco with their Nexus 1000V, extending their physical switch management into the virtualized environment, which is very valuable for Cisco customers who've already got that investment in Cisco technologies. There's extensions that plug into the UCS hardware platform, the VM Fabric extender. So there's been a lot of work done that helps to integrate the layer 2, the Microsoft switch, the extensible switch in Hyper-V, and those partner solutions. From NEC, the OpenFlow, the first OpenFlow capable vSwitch, the programmable flow PF1000. So for NEC customers who are running OpenFlow within their environment, again, another example where you can just plug in and start to integrate more deeply at the Hyper-V virtual switch layer with that existing investment. For customers that are looking at security, Five9 with their Security Manager product and a virtual firewall provide very granular configuration of both the firewall and an agentless antivirus solution, all within that Security Manager package. So it enables me to spin up lots of virtual machines without needing to put a virtual agent inside that virtual machine for the antivirus, for instance, which some people believe is a more optimal way of providing AV within a virtualized environment. Agentless and offloaded some kind of appliance or some kind of central source. And that's what the Five9 solution does. But to do that, it plugs in through that extensible switch. So by providing this framework to Five9 as an example, they've been able to go deep inside the virtual switch and build an extension that reaches into the VM effectively without needing to put an agent in the VM and communicate through normal network channels. So that's very, very valuable and very deep and integrated with Hyper-V. But that would be a different extension point to that of Inmon with their S-Flow product, where they're really interested in monitoring the infrastructure. So they're interested in getting the information from the virtual machine, what's going on from the traffic. And again, with the extensible switch, they can start to capture some of those metrics, some of those pieces of information that are traveling between the virtual machines and build some very powerful visualizations of just what's going on in the network. So you've got lots of key features that are exposed by the networking switch for monitoring, for life cycles, for state changes, for, again, multiple extensions all on that same switch, for firewall, for antivirus. There's lots of different capabilities, and these are just a few. These are just a few examples. And what I want to do in a quick demonstration is actually explore some of these. Look at some of the extensible switch capabilities so you can understand just how extensible switch extensions plug in and how they bring value to the environment. So let's take a look at that in a quick demonstration. Okay, here we are back on our Windows Server 2012 R2 Hyper-V host. And if I bring up Hyper-V Manager, we're just going to explore some of the settings, some of the options we have around configuring and exposing that Hyper-V Extensible switch. And to do that, firstly, I'm going to take a look. I've got our Hyper-V 05 host, and we've got a number of workloads running as we've seen. And I'm going to go into Virtual Switch Manager. And Virtual Switch Manager, as the name suggests, allows me to create Hyper-V virtual switches, of which there are 3 types exposed through the Hyper-V UI. There's an external switch that allows VMs and the host, if you so choose, to communicate out of the physical adapter on that host and off onto the network. There's an internal network, which essentially creates like a loopback adapter that essentially allows the Hyper-V host and the VMs on that host that are attached to that particular vSwitch to communicate with one another. But any VM that is outside of this particular host can't communicate within on that internal virtual switch. It's a host-specific switch that's created. And then finally, the private vSwitch, as the description below provides us, states that we can only communicate between VMs on this single host for virtual machines attached to that particular private vSwitch. So not even the host can communicate via a network with the VMs that are attached to this. It's a VM to VM network. So VM to VM, VM to VM and host, and then finally external allows all virtual machines and hosts to communicate if they're attached to that particular vSwitch. Now, if we were to create one of our own, you'll see here I get the opportunity to name the virtual switch. I can call it whatever I like, and then I choose to bind it to a particular network adapter within the host. So this is us essentially creating and transforming a physical NIC or a NIC team that you've already established, like the one here. This network adapter multiplexer driver is an example of a team. It essentially binds our NIC or team with a virtual switch and transforms it into a comprehensive extensible virtual switch that allows the host and VMs to communicate out via. Now, there's a couple of extra settings we should be aware of. This first one, allow management OS to share this network adapter. If I tick this box, when I bind this vSwitch to the physical NIC that's chosen here, that physical NIC is going to lose its TCP/IP settings. It's going to be transformed into an extensible switch. So it's going to lose its IP address, its communication via that initially. If I leave this little box ticked here, this allow management OS to share, what that's going to do is Hyper-V is going to create a virtual NIC for the host, for the parent partition, to communicate out via that particular vSwitch we're just creating. Now that's optional, and in a production environment you would probably dedicate vSwitches to virtual machines and have a dedicated management NIC or NICs for the host management, so you may choose to untick that on that occasion. We have a couple of other settings aside from VLANs as well. This important one here, SRIOV, that we talked about earlier. The ability to present a virtual function from a physical NIC through to a virtual machine. Now, to do that, we first need to enable SRIOV at the switch level, and that may require configuration of your BIOS to support SRIOV. Your NIC firmware will probably need to be up to date as well, so a couple of key considerations. But the key thing here is I need to enable SRIOV when I'm creating the switch, else I won't be able to use it with virtual machines later on in their VNICs. That's something I've got to bear in mind. I'm going to leave that for now, and I'm going to explore and expand this little tick box next to the switch itself where I've got extensions. Now these can only be managed after the switch has been created, but fortunately I've already got a switch that we've created, so I'll expand this one and click extensions, and you'll see there's a number of extensions that have already been incorporated across monitoring and filtering. 2 of these are core in the box with Windows Server, the NDIS Capture and the Windows Filtering platform, but this VMM extension was used by VMM when it installed and started to manage this particular Hyper-V host. And if you choose to install extra extensions from Five9, from Cisco, from NEC, from Inmon, they're going to appear in this list, and you can choose to tick and turn them on or tick to turn them off, whatever's going to be appropriate for you. Now that's a little bit about the virtual switch itself, and every single Hyper-V switch that gets deployed is extensible, and it's the same vSwitch that gets deployed on client Hyper-V as server Hyper-V, which means I can develop an extension on a client machine and transport it and port it over as a developer onto a server environment, which is very, very useful. However, I'm going to cancel out of there and not apply my changes, because I'm going to look at the settings of this particular VM, the one we've been focusing on a fair amount, DB01. And I'm going to expand network adapter And you'll see there's a couple of extra choices I can make. Firstly, hardware acceleration, which allows me to take advantage of existing offloads in the physical NICs to which this particular VM's virtual network adapter is bound to. So for instance, on our host we saw that we had a vSwitch of Corp, and this VM is connected to Corp, and therefore we have exposed to us a number of the hardware characteristics of the physical NIC, should we choose to use them. In this case we could choose to use VMQ, which we learned about earlier, to help optimize the processing of traffic. IPsec task offload, which helps us process the encryption decryption associated with IPsec off to the network adapter. And then finally there's that SRIOV. So we can turn that on specific to this particular virtual network adapter and this particular virtual machine. Even if I tick this, if I haven't enabled it on the vSwitch in advance and I haven't enabled it at creation time, it's not going to do anything. I'm not going to benefit from an SRIOV NIC inside the guest. Now those are specific to hardware acceleration and driving higher levels of performance, but we also have some advanced features around security. So for instance, you'll find MAC address spoofing, DHCP guard, router advertisement guard. If this is a protected network, a new feature in Windows Server 2012 R2, where if the cluster and the Hyper-V itself detects that this particular virtual machine has suffered a network disconnection, we can move it to another cluster node where that network is still operable. So again, very, very useful, a new capability enabled or disabled here. Port mirroring, so mirroring traffic between virtual machines for perhaps analysis or traffic sniffing. And then finally, if this NIC is going to be a team inside the virtual machine, so maybe you've got a VM with multiple vNICs, and those vNICs are attached to multiple vSwitches, and those vSwitches, which are actually physical NICs, are attached to actual physical switches that are separate, multiple levels of resiliency, that's pretty useful. So ticking that box is going to enable that feature or that piece of functionality. But there's a couple here we've discussed in the slide that aren't present in the UI, like virtual port ACLs or trunk mode to virtual machines. And those kind of configurations are all made through PowerShell, or Virtual Machine Manager actually exposes some of those as well. But through the Hyper-V UI, what we see here is on the screen is what we can configure through the UI, through the GUI. If we had PowerShell capability, which for me, I'm not going to show today, but you could very easily find on TechNet and start to implement some of those key configuration changes using PowerShell against these Hyper-V virtual machines and vNICs. But hopefully that just gives you a little quick look around the Hyper-V virtual switch, the Extensible virtual switch, and how that reflects into the virtual machine as well. And with that, we'll go back to the slides. And welcome back after the demo. Hopefully you found that useful and it opened your eyes to some of the extension points within that Hyper-V extensible switch that partners, that yourself, you could write and you could plug into. Remember, Windows standard frameworks, management interfaces, if you've got dev skills, or even if you're not and you're looking to learn, you can build something that plugs into Windows Server 2012 R2 and enables you to really start to extend the solution in a way that's relevant for your environment specifically. Now that's a bit about isolation and security at the network level through that very, very important extensible switch. But we mentioned also compliancy. Compliancy is important for a lot of organizations to meet certain compliancy guidelines in public sector, in government, wherever it may be. And one of those may be encryption. You may have a requirement within your environment that all your data resides in an encrypted environment. How do you do that in a virtualized environment? Not many of the virtualization vendors out there provide encryption in the box. Maybe it's something you can buy through a third-party add-on. Maybe it's not. Maybe it just doesn't provide you with that capability. But with Windows Server 2012, R2, and Hyper-V, we've got that in the box through BitLocker drive encryption. Now, I gave the example earlier as people leave laptops in airports, in taxis, all over the place, and that's the kind of device that protecting and encrypting your data is typically associated with. But what about servers? Yeah, if you're in a secure data center where there's multiple levels of security to get to the physical server, that's not going to be easy. BitLocker may not be as relevant in that environment unless you've got a specific compliancy requirement. But for less physically secure locations where somebody could walk in with a fake badge that they've created in Paint that can be very effective, they presented it to the front desk and said, I've come to fix your server. I've been sent by IT. I know there's a problem with it. Okay, yeah, there you go. There's the server room, which is a cupboard. They've opened it up. They've taken the server out. I'm going to have to take this to my head office, and out it goes out of the door. And never to be seen again. Extreme situation, but that data is now gone. And if you've got multiple virtual machines on there, that's gone as well. There could be a lot of repercussion based on that situation. And yes, it's extreme, but BitLocker could help. BitLocker will encrypt the data. It now supports a feature known as used disk space only, which means BitLocker encrypts on the go in terms of as you use more space on the disk, it's encrypted at time of use rather than encrypting all of the drive at the start, which wasn't an option in previous releases. It integrates with the TPM chip on hardware, which if you're buying servers and you may need encryption, something to think about would be, does my server have some form of TPM chip that I can utilize to enhance that encryption? But for lights out environments where you don't want to have to enter a PIN, because one of the capabilities of BitLocker, or one of the requirements in some scenarios, particularly in laptop scenarios in Microsoft IT anyway, is where you first boot your machine from cold or reboot it, you get prompted to enter a PIN. Now, if you're 5,000 miles away from your server, you're not going to be able to enter that PIN. And it's difficult to enter it at that time. Maybe you've got lights out where you can enter it. Maybe it's even too early in that process. So we have to think about how I can enter that PIN, or perhaps not need to enter that PIN, providing that server is on the network secure. And that's where network unlock and the integration with Active Directory comes in. So if that server is residing on your network, it can communicate back at point of boot and check, okay, I'm on the network, I'm safe, I'm secure, I don't need to prompt for the PIN. I'll just go into my regular boot process. But if it's been stolen and it's now on somebody else's random network, or not at all, it makes that check, fails, prompts for the PIN. They don't know the PIN. Data's encrypted and secure. So good stuff. Now, when we think about Hyper-V VMs, I mean, this is the host we're talking about here. We're not talking about inside a VM. We're talking about the host. If I think about this host, I need to encrypt the underlying disks that VMs reside on. And if I've got local disk inside the host, DAS storage, loads of disks shoved in a tower machine, and I've encrypted them with BitLocker, my VMs that have been placed on there also encrypted. Great. But if I introduce a storage array and I present a LUN from that storage array, either iSCSI or Fiber Channel, to that host, and it's exclusive to that host, and I turn on BitLocker and I encrypt it and put files on there, great, they're also encrypted. So DAS storage and traditional LUNs that are presented from the SAN. But what about cluster shared volumes? Well, in 2012 Windows Server, we introduced support for encryption of cluster shared volumes, which means as a CSV volume, so a traditional LUN that's been marked as a cluster shared volume, remember from part one, CSVs allow multiple VMs to reside on a LUN. So a cluster shared volume, which appears, if you look on the slide, as C drive / cluster storage / volume 1, 2, 3, 4, whatever. The VMs that reside inside of there, that LUN, that underlying storage, is also encrypted. So again, CSVs, traditional LUNs, and local storage. But if you're also using the new Hyper-V over SMB scenario, where you've got effectively virtual machines stored on a file server, then you've got the opportunity to encrypt with BitLocker on that file server. So again, that's not necessarily taking place on the Hyper-V host itself, but you're encrypting on the file server where the VMs reside, where their virtual disks reside. So flexible choices, file servers, Windows Server 2012, R2 file servers, CSVs, LUNs, and DAS storage. Lots of flexibility there. And that brings us to the end of that security and the multi-tenancy. And we'll look a bit more at multi-tenancy a bit later on when we talk about network virtualization. But we focused a lot on flexibility just in that BitLocker example. Flexible choices for placing virtual machines and their disks that are running on encrypted drives. Now, when we think about flexibility broader within the Hyper-V environment, we're thinking about what guest operating systems can I run? Where can I move virtual machines? Can I move virtual machines around? And Windows Server 2012 introduced a number of new capabilities to enable flexible movement of virtual machines around that infrastructure, from cluster node to cluster node, even in and out of clusters, and we'll explore some of those features shortly. But we also introduced capabilities that made flexible networking capabilities more easily accessible to customers. What I mean by that is the ability to flexibly deploy and manage networks in a way that's radically different from what's been done before. Software-defined networking is a good term to use to amalgamate some of these network capabilities. building, deploying, and managing networks with software, all with Hyper-V and through System Center. And we'll look at some of that as well. But what are some of the key considerations and challenges that people make when they're thinking about networking and flexible infrastructure? They want to be able to move workloads around without interruption and downtime. That is almost the number one line item for a virtualization requirement proposal now. Must be able to move virtual machines around with no downtime. It's a given. It's almost expected now. That capability was introduced in 2008 R2. Hyper-V has been streamlined and enhanced in 2012 and now even more so in R2. And you're going to learn how and how that's really cool a bit later when we go forward. We want to be able to isolate workloads. We touched on security and isolation a little bit earlier, using VLANs, PVLANs, and some of the isolation and security capabilities within the virtual switch, the extensible virtual switch. But what customers are asking for is, help me simplify. I don't want to rely on VLANs. VLANs are going out of control. They're coming out of my ears. They're everywhere. I can't handle how many VLANs I'm having to manage. And my switches are running at capacity. And I know I'm going to go plow through and buying new switches and having to reconfigure all the new switches is going to be a pain. Can I do something that's a little bit easier? I've heard about software-defined networking. What's that all about? We'll talk about that as we go forward. What if I want to have a situation where I've got a virtual machine that's running, it's running great, but it develops an error. The virtual machine is still running, users are still using it, but there's an error. There's a problem on that VM that could escalate. I need to get that virtual machine into the hands of my testers, my devs who built the application that's gone wrong, but I can't take it down because users are still using it and it's not failed yet. What can I do? What can I do in that scenario? Well, in 2012 R2, we've introduced capabilities to enable that solving of that scenario, which we'll explore in a minute. A lot of people think that Microsoft Hyper-V in Windows Server 2012 and 2012 R2 is all about Microsoft VMs, Windows Server, Windows Client, but it's not. It's about other operating systems as well, Linux operating systems, a wide number of Linux operating systems that are now supported on Hyper-V. And we'll look at some of the, not only what's supported, and I'll briefly discuss, but I'll also talk about what we're doing to really enhance the performance of those workloads specific to the Hyper-V environment. And finally, when it comes to new releases of Windows Server and Hyper-V, sometimes it poses a difficult question with customers back to Microsoft. It's like, right, great, this capability looks amazing, Windows Server 2012, phenomenal, you've blown my socks off. How do I get there? I'm on 2008 R2 today, Hyper-V, I've got X number of VMs, I want to go to 2012. Can I get there and can I do it with no downtime? And it's kind of like one of those, there might be a bit of downtime. 2012 R2 has introduced new capability to solve that very problem. So we're helping customers move with us as we introduce new releases of the virtualization platform in a way that's streamlined and seamless for that particular workload. So helping them to really move and embrace and take advantage of these new capabilities that many of them are licensed for, but without the headache of downtime for the key workloads that are running on top. So what have we introduced? Well, when we think about live migration, we introduced things like simultaneous live migration in 2012, where we're moving virtual machines around from host to host simultaneously, so multiple VMs moving at the same time. Moving the storage around flexibly without downtime to the virtual machine. Upgrading with live migration from one version to another. Moving virtual machines with hardware enhanced, let's say, hardware enhanced migration. So moving virtual machines, taking advantage of some of the networking hardware that our partners are delivering to the industry to really accelerate and streamline how fast we can live migrate virtual machines across from one place to another. Network virtualization, transforming the way we build, deliver, and manage networks, all through Hyper-V and through System Center, in a way that is effectively easy to consume, means that you don't have to change your networking hardware, but allows you to take advantage of the capabilities all in the box. And then we think about how we move virtual machines even more flexibly in and out of clustered environments. That's where technologies like shared nothing live migration come in. All of these things we're going to look at in this section. So when we think about Linux support, we think about what are we doing? What have we done so far? We've been working with the Linux community for a number of releases now to really enhance how well Linux works on Hyper-V. So working with that community, establishing a better quality of driver, Hyper-V driver, for the Linux OS, whether that's commercially supported Linux distributions like Red Hat, or whether that's freely available distributions, those supported by the community. We've worked hard to ensure that the drivers are up to an optimum quality and are now so far up in the tree that many distributions that are now being built from those root distributions and the root kernel are now have the Hyper-V drivers contained within them, which means when you run a Linux distribution on Hyper-V, there's no tweaks, there's no tailoring, it's optimized by default. It's got the Hyper-V drivers in by default. Now there are certain scenarios where you have to implement the drivers separately, and we make those available. So perhaps for slightly older Linux distributions, you can download the drivers, import, and away you go. But either way, you're getting an optimized Linux distribution with Hyper-V drivers that have been optimized through work with the community and with those commercial vendors. And it's not just about saying, yeah, it runs great, it's also about support. So Red Hat, OpenSUSE, SUSE, CentOS, Ubuntu, and more, all of which you can find on TechNet, are all supported on Hyper-V. Supported as in, I can ring Microsoft and ask for help. So not only are we supporting more, but we're delivering more innovation into the capabilities of those guest OSs as well. So 64 virtual proc support, the virtual SCSI controller, which allows hot add of virtual SCSI drives. It also allows the online resize that we talked about in part 1 of the session, where I can extend and shrink a virtual disk attached to a Linux virtual machine. Full dynamic memory support, which was a key ask of the Linux community. We want to be able to scale up and scale down the memory that's been given to a Linux virtual machine in the same way we can for Windows, and that's coming with 2012 R2. So you're now able to take advantage and increase your density using dynamic memory for Linux and Windows workloads. A key capability is live backup. Linux doesn't have a VSS writer in the same way that Windows does, a VSS capability. So with Windows Server 2012 R2, we've worked hard to build an engine of backup that enables us to snapshot and backup a Linux virtual machine effectively without the need to take it offline necessarily. So we're able to provide a lot more rich capability, even more capability than what exists for Linux in the physical world, is built into Hyper-V and built into the virtualization layer. So real power and deeper integration with the key services like keyboard, mouse, common stuff that you'd expect just to work. Keyboard, mouse, integrated shutdown, time synchronization, all of those integration services that make the experience optimized. And when you look at the diagram in the slide, you'll see enlightened mode for a Windows client, enlightened mode for a Linux client. So we're trying to achieve parity, optimized devices, optimized drivers, optimized performance running on Hyper-V for both Windows, as you'd expect, and for Linux distributions as well. So it's not just about Linux, and I urge you to try out some of the Linux distributions for yourself running on Hyper-V, because I think you'll be pleasantly surprised. But when we think about virtual workloads running on Hyper-V, and go back to the example I used earlier, we've got a workload running, it's had a problem. The application could fall over, there's an error been raised, we can't take it down, but I need to get it into the hands of the dev team. And that's where virtual machine live cloning or export comes in, which allows me to duplicate a virtual machine while it's running. Some of you may be familiar with the export capability within Hyper-V, which allows me to export a virtual machine to another place, a USB drive, a local drive, whatever it may be. And once I've exported it, I can import it somewhere else. But I had to have the VM shut down to do that. Well, with Windows Server 2012 R2, I can effectively clone or live export a running virtual machine while it's running, so no downtime. So I can effectively initiate the export. Hyper-V performs a live point-in-time export of the VM, which stays running, and it creates the new files in the target location. Now imagine that scenario, that dev team needs to get access to that VM. It's a point in time, we don't want to rebuild the VM because we might not be able to recreate the problem. We want to capture that VM as it is with the problem. That live export will help with that. I can take those files, give them to the dev team, they can spin them up in their environment, whether that's on a server running Hyper-V or Hyper-V client within Windows 8 or 8.1. They can spin that up and they can start troubleshooting. Now, the admin would then import the new powered off VM on the target host. Remember, it's identical, so you don't want to power it on on the same host or in the same environment, because the NICs, the MAC address, everything's going to be the same. So you would have the Active Directory names and so on. There's going to be a domain issue. So you want to bring it up in an isolated environment. If you're using System Center Virtual Machine Manager, as part of the export or clone process, there's a bit more of a wizard that enables you to select a target destination or host as part of that cloning. If you're doing it with raw Hyper-V Manager, it's a little bit more of the export process and then the import process separately. So you've got a little bit more granularity and control with Virtual Machine Manager. But one of the cool things about this is, if your VM is just a regular VM with one disk, great. Right-click VM, export, off it goes. If your VM is one that's got checkpoints, what were known as snapshots in previous versions, so now they're known as checkpoints in Windows Server 2012 R2. If it's got checkpoints associated with it, you could select one of the previous points in time in the tree, right-click, export, and it will export and create a full VM from that snapshot. So it will take the original base image and the snapshot point in time and then merge them into a new VM for you. So you could create lots of exported VMs from different snapshots in points in time. Very useful for troubleshooting, for devs, and so on. A really cool scenario that we've introduced in 2012 R2. That's a bit about cloning and exporting, as it's termed. But what about moving stuff around? We don't want to export VMs all the time to move things around flexibly. There's got to be a better way, and that's where live migration comes in. And live migration, as I said earlier, was introduced in Windows Server 2008 R2, Hyper-V, and enabled me to move a VM from physical host to physical host with a cluster. So there had to be a cluster set up with shared storage, but I could only move one VM at a time between two nodes. Now in 2012 and in 2012 R2, live migration is faster, taking full advantage of the networks you've got between your Hyper-V hosts for that migration. But more importantly, it's got a simultaneous live migration. So if I've got a really heavily loaded Hyper-V host with lots of VMs, and I click maintenance mode, and it wants to evacuate all of those VMs off that host as quickly as possible, rather than do one at a time, it's going to spider web out and evacuate those VMs to multiple different other cluster nodes as quickly as it can. So it's going to send one VM to node 3, one VM to node 4, one VM to node 7, one VM to node 10, whichever it feels are best to distribute to. But it's going to do it simultaneously with a user-defined maximum number of migrations at one point. So you can specify it as 1, 2, 5, 10, 99999. It's about 10 digits you can put in there. So you could do 9 million migrations at once. If you've got that many VMs, it's going to go really slowly for each VM, but you could do it and probably wouldn't be recommended. But there is guidance out there on the web as to what your recommended number should be. And it all depends on your environment and your workloads. We think about 4 simultaneous migrations for gigabit and 8 for 10 gigabit network connections that are used for live migration is a pretty good starting point, a good ballpark figure. But once you've defined that, when you kick off the maintenance mode, the migrations are going to go and queue up the migrations that can't execute at that point because you've reached your maximum number. If you want to increase performance, and we'll look at this shortly, you can take advantage of certain hardware innovation that can really drive forward the performance, and we'll look at that shortly. But one of the new key things that we've introduced in 2012 and 2012 R2 is this concept of storing the virtual machine's files on an SMB share. So you'll notice in the diagram there, we've got the live migration set up. You could use iSCSI, Fiber Channel, or SMB storage now in 2012 and 2012 R2. So imagine all of my stuff, all of my files, my virtual disks, my configuration files are all on an SMB share. I don't need a cluster to be able to migrate virtual machines between two hosts. As long as I've got those hosts that can both see the SMB share, I can migrate them across. So I can send the config data first, as with a normal live migration, we set up the skeleton VM on the target node, and then we transfer the initial memory. But as memory is changing, we go back and we transfer the modified memory pages, so just the deltas. And memory is always changing, but if the rate of change of memory is less than our transfer speed, that live migration will finish quickly. If the rate of change of memory is really high and we can't transfer memory faster than it's changing, we will slow the VM down with something called stun during page send. So we'll slow the VM down so that its changes aren't as rapid, so it enables us to migrate the memory quicker or keep up at least and exceed the rate of change of memory, and so we can get the live migration to finish. And now the VM is running on the target node. The storage has stayed where it is, but we've just changed the handle. So now it's changed and attached to the target host. So that is live migration. The key changes in 2012 and R2 were that speed and that simultaneous nature of live migration. But we also introduced key improvements in 2012 R2, specifically to R2, that drive performance even higher for live migration. Because you could think, well, live migration is live migration. It should just, how can you make it faster? The network pipe is only so big. If you've maximized your pipe, the only way to go faster would be to add more pipes, surely. Yeah, that's one way, but there's another way to actually speed up live migration using the same size pipe, and that's with compression. Think about a host, a Hyper-V host. Is it at 100% CPU utilization all the time? No. We can take advantage and utilize some of those spare CPU cycles to compress the memory that is sent across the network during the live migration. So same setup process for the live migration. We set it up, we connect the two nodes, we send the config data so the skeleton VM gets set up on the target site. We compress the memory using the spare CPU cycles on the source host and send less memory across the network therefore, so it finishes faster. And then any change pages, so the delta changes, are also compressed and sent across the network. So we're sending ultimately less data across the same pipe using the remaining CPU cycles on the target host to handle that compression. If there's no CPU cycles available on the source host, we won't compress. Compression is on by default in 2012 R2. We send less memory across the network. It operates on networks with less than 10 gigabit bandwidth available. And we've seen in our tests and our demonstrations at recent big events like TechEd and so on, a 2x performance improvement in live migration on the same size configuration. So we're able to rapidly accelerate live migration twice as fast, which means the workload is in that migration phase for less time and there's less performance impact to the workload. Because no matter what anybody says, there is a slight performance drop-off of workloads when you're moving the virtual machine around, whether it's on our platform or competitive platforms. It's not a no-cost operation. But this can help it complete faster, so the cost is reduced. That's compression, and that's on by default in 2012 R2. But there's more. I mentioned earlier taking advantage of hardware. We mentioned it in part one. I've referenced it in this particular part as well. Hardware vendors are innovating at the network silicon level, bringing in new capability to help us offload certain tasks to the NICs, where they can be processed and streamlined and made more efficient. RDMA is an example of that. Remote Direct Memory Access. There's a new acronym for some of you, I'm sure. RDMA delivers effectively low latency network, CPU utilization, and higher bandwidth. So we're lowering latency, lowering CPU utilization for transferring and processing network. Because think about it, when you're transferring a live migration of a VM, network traffic is happening, and it can be happening at quite a big rate. So if we're transferring a lot of data, we're going to need CPU cycles to do that on the hosts. So that's going to consume some resource. If we can offload that to the cards that have this RDMA capability, where you'll see speeds of 40 gig, 56 gig, 100 gig is coming, that's a phenomenal speed, but the card is handling the processing of that. Windows Server 2012 R2 supports ROCE, so RDMA over Converged Ethernet, which is actually a nested acronym there. So you don't see many of those. RDMA over Converged Ethernet, ROCE. One for the internet searches there, just to check up on that one. ROCE, which operates over regular Ethernet. So you don't need to do too many changes to your infrastructure to take advantage of that. You may find you've already got RDMA capable NICs in your servers. They don't take different adapters, they don't take different switches, so you may be able to start to see some advantages. But some of the higher end speed RDMA NICs, the InfiniBand type connections, they may require bespoke type cables and connections. Companies like Mellanox are one good example of a company that are providing RDMA network adapters with specific InfiniBand type connectivity. But the speeds they can reach for this connectivity are phenomenal. Phenomenal speeds. But what's the benefit? Well, as you can imagine, utilizing these NICs with those kind of network speeds, with the low latency and low CPU utilization and high bandwidth, means that migration can operate orders of magnitude faster than it would have done in previous releases of 2012. So we send the config data, you don't quite get the impression from the animation, it happens so fast, but that's intentional. It sends the initial memory, it sends the modified pages, and boom, you're done. We've done demonstrations at TechEd, and if you've not seen the conferences, check out Channel 9 and you'll see the recording of the keynote demonstration. We've done demonstrations where a migration of 2012 Hyper-V VM to 2012 Hyper-V VM, the migration of that VM took around about 1 minute, let's say 1 minute 20 seconds. We turned on compression, we migrated the same VM config, the same VM, from a 2012 R2 to a 2012 R2 host with compression. Took around about 30 seconds, 35 seconds. So we slashed it in half. We then did the same migration over RDMA. So using RDMA network capability. It's actually SMB direct. It went down to 9 seconds. So we've gone from 1 minute 20, over a minute, to 30 odd seconds, to 9 seconds. Utilizing the hardware. Phenomenal performance. And at this point in time, Microsoft is the only vendor that supports live migration over RDMA, utilizing those kind of network adapters for that. So if you're investing in hardware going forward, the key moral of the story, think about RDMA capable hardware, whether it's ROCE, RDMA over Converged Ethernet, or something more bespoke and unique that's going to give you the higher speeds. And like I say, at this point in time, 40 gig, 56 gig, 100 gig is on the horizon. Migrating VMs at 100 gig Ethernet is going to be it's going to finish before you've clicked. It's going to be that fast. I mean, that's technically impossible, but it's going to be fast, all right? Trust me. It's going to be really, really fast. We've done tests internally to give you a bit of insight into, how we get extreme on this. We've added a couple of these cards to our servers. So imagine 2 hosts with multiple RDMA capable cards. So we're at 56 gig times 3, for instance, per host. So we've got a pipe that's huge. We found that migrating VMs on that kind of infrastructure, because live migration over SMB, which this essentially is SMB protocol, will use each and all of the networks between the hosts. So it will send down each of those pipes. We found that the bottleneck in that live migration, the speed, what ultimately determines how long it takes, isn't the disk, it isn't the network itself, it isn't the CPU processing of the traffic, it is the actual speed of the RAM in the servers. It just cannot keep up with what we're trying to do. We're sending data so fast that the RAM couldn't keep up. So it's just a phenomenal example of where we can take advantage of hardware investments and ping VMs around at lightning speeds. And that's all in R2, it's in the box. But you would use that on higher speed networks. You'd use compression on lower speed, 10 gig up to 20 gig. Higher than that, when you've got multiple NICs, you'd look to RDMA. But remember, it will require specific RDMA hardware to support that. But that's moving the VM state and leaving the disk where it is. In Windows Server 2012 and now in R2, we also introduced the ability to move the virtual disk while the VM is running. So we're leaving VM where it is, but we want to move the virtual disk from storage array to storage array, from LUN to LUN, for instance. So here in the diagram, we've got a Hyper-V virtual machine running on a host, and the virtual disk is running on the source LUN, let's say. And we want to move that virtual disk across to another LUN on the SAN or another location. Hyper-V will effectively initiate the process, create a new virtual disk on the target device, and start populating it. Start populating it with content. Reads and writes from the VM are going to the source, but these are being effectively transmitted across to the destination as well. But when we get to a point where the destination virtual disk more or less matches the source, there's going to be a period of time where we need to write to both. So all of our writes, as you can see from the diagram, are not only going to the source virtual disk, but they're going to the target virtual disk as well. And then we flick over control. And the virtual machine is then completely connected and only connected to that source virtual disk, that virtual disk in the target location. So great flexibility, moving storage around with no downtime. We can change the virtual disk storage location flexibly, gives administrators lots more flexibility, and it's a process that's accelerated by ODX, which we talked about earlier. Offloaded data transfer being that, here Mr. SAN, this is a storage related task. Can you do this please? Thanks very much. Off you go. And does it like that. So rapid. Again, hardware investment benefiting Hyper-V. And it's all in the box. There's no specific SKU for this particular configuration. So that's a bit about storage migration, and that's with initiated through the GUI, with PowerShell, however you want to trigger it, that's up to you. You've got that flexibility, but it's really, really useful. And again, it's in every edition of Hyper-V. But wouldn't it be great if I could move the running state of the VM and the disks simultaneously, but with no shackles, no clustering requirement? Yeah, that would be great, and that's why we did it in Windows Server 2012, and it's also in Windows Server 2012 R2, in the form of something called Shared Nothing Live Migration. Now, Shared Nothing Live Migration, essentially, as the diagram is animating, moves the running state of the virtual machine, so the memory, and the virtual disk simultaneously. Now, the order it does this is it will transmit the configuration data to get that VM ready on the destination Hyper-V host, and it will then do the disk bit, because let's face it, the disk bit is probably going to take the longest. It's going to take the most time. It's going to be a process that does take a little while to copy all those files, depending on the size of your disk. Once that gets up to the stage where the disks are more or less in sync, the mirroring will take place, where the reads and the writes specifically will go to the both source VHDX or VHD and destination, and then we'll flick over control while moving the memory content of the virtual machine from A to B, the change pages, and then all in one, everything will be migrated across and off we go. So the virtual machine state and its disk has been moved simultaneously. This could be from standalone Hyper-V host with DAS storage to standalone host with DAS storage. From standalone host with DAS to another standalone host with SAN storage. From standalone host with SAN storage into a cluster with SAN storage. From a cluster out of a cluster to a standalone host. You get the idea. Complete flexibility to move it wherever you want, but it's simultaneous, VM and disk at the same time. And we were the first to introduce this in a hypervisor platform, in a virtualization platform. Our competitors had this months and months later. This was introduced in Windows Server 2012 first. All you need between your hosts is an Ethernet cable. Can the hosts see each other on the network? Yes. Okay, great. Shared Nothing Live Migration will work. Couple of configuration items to configure security-wise. We don't want people pinging VMs all over the place to insecure locations, so they've got to be able to communicate effectively securely and trust the places where they're going to be communicating to. But the boundaries of cluster migration are just smashed. They're broken down. We can just move stuff flexibly around. And let's show you. Let's have a look. Let's look at some of these virtual machine migrations and the impact that the changes and improvements we've made on Windows Server 2012 and R2 can really have on moving those migrations and moving those workloads around. So let's take a quick look. Okay, so here we are back in our environment where we're going to look at our Windows Server 2012 R2 Hyper-V host. And for that, we're going to start to look, before we look at the actual migrations and moving virtual machines around, we're going to start to look at some of the settings, some of the controls that we have around migration, and some of the new capability that was included within 2012 R2. And to do that, we're going to open up Hyper-V Manager. And you'll see on the left-hand side, I'm actually managing more than just the one host now. So I've got a few hosts. But we're going to be focusing in this first part of the demo on Hyper-V 01, just to look at some of the settings that are enabled within the environment. So I'm going to look at Hyper-V 01. I'm going to go over to Hyper-V Settings. And you'll see in here I've got a number of different settings that associate with the particular host, and we're going to click on Live Migrations. And this is where I can specify the number of simultaneous live migrations that are enabled for my particular Hyper-V host, both simultaneously sending or receiving, incoming and outgoing as it's listed at the top. And I can specify any number up to 9 or 10 digits long in this box. So realistically, there's an unlimited number of simultaneous migrations you can perform to and from a host, which isn't necessarily a best practice. You'd want to model that number you put in that box against a specific your workloads, your testing that you've done performed within that environment. But generally 4 for gigabit, 8 for 10 gigabit networking is a reasonable figure to start with. Now I'm going to choose 4 for the time being. And here you can also specify specific subnets, specific IP addresses that are used for live migration. So that's useful in cluster environments, but even useful in standalone environments, as we'll see shortly. But I'm just going to leave mine as pretty flexibly configured for any available network. Now we also scroll down, in fact we expand with this little plus icon, and we can click on Advanced Features. And this wasn't here, this option wasn't here in 2012 Hyper-V, but now we've got a couple more options. We can choose our authentication protocol, where the CRED SSP, so Credential Security Support Provider, means we must be on that particular server to initiate the migration from that server to another. Alternatively, Kerberos gives us a more secure option, but if we want to migrate virtual machines from a host that we're not currently logged into, that means we need to set up some constrained delegation, of which there's plenty of guidance on TechNet and online that can help you do that, but that involves a setting that we make at the computer object level within Active Directory. But either way, that's pretty straightforward. Some of the new stuff that's been enabled within 2012 R2 is a couple of different types of performance options for live migration. TCP/IP being the standard, where the memory of the VM's copied over the network using just a regular TCP/IP connection. But the two new options are compression, which utilizes CPU cycles remaining on the host to compress memory as it's transferring it across the wire, so transferring that state to the memory, or SMB, which is utilizing multiple SMB connections to transfer that. So the more SMB connections you have, the faster that's going to go. And if you've got SMB direct, so you've got RDMA capable NICs, then you're going to be able to accelerate live migration phenomenally quickly. But I don't in my environment, but if I did, I'd have that option here to tick. I'm just going to use compression. Now finally, in terms of the settings, so I don't want to come back here later, this is where I can specify the simultaneous number of storage migrations that are going to take place at a single point in time, incoming and outgoing. So similar to what we saw before with 4, I can put a number in here for storage migrations as well. Now that's specific to configuring the Hyper-V host, and you can configure all of that through PowerShell as well. And I'm going to go OK. And for our first look at migrations, I'm not going to stay in Hyper-V Manager. I'm actually going to minimize here, and I'm going to open up Failover Cluster Manager, which is going to give us a way of looking at and administering virtual machines that are already highly available on top of a cluster. So let's take a look at that. So I'm going to open up Failover Cluster Manager, and you'll see on this cluster I've got a 2-node Hyper-V cluster, so not particularly big, but I have actually got a couple of virtual machines already running within this environment, VM01 through VM04. And one of the new features that was introduced in 2012 Hyper-V was the ability to simultaneously migrate multiple virtual machines between hosts at the same time. So I'm actually going to select all, I'm going to right click, and I'm going to go to Move, and you'll see I've got a couple of options: Live Migration, Quick, which is actually going to incur some downtime or a pausing of the virtual machine as it moves. And both of these options are going to leave the storage where it is currently in its shared location. So we're just moving the running state of the VM. Alternatively, I can move the storage, and we're going to explore that shortly. But firstly, I'm going to go Live Migration. I'm going to select the node, and I'm going to choose Hyper-V 03 as our node that we're going to migrate the virtual machines to. And what you'll see is that migration will kick off, and you'll see they're all migrating simultaneously, going pretty quickly. Now those machines aren't particularly big, but that's finished now. So we've moved the memory across the network as quickly as possible, and those virtual machines will continue on running with no downtime or interruption. And that was initiated through the cluster UI, because these VMs are clustered objects, they're highly available, but I could have triggered that through PowerShell as well. Now some of the other new capability that was actually introduced in Windows Server 2012 Hyper-V, if I go back to Hyper-V Manager and go to one of my hosts, Hyper-V01, that is standalone, it's not actually using shared storage and it's not clustered, and I'm going to actually perform a different type of move, where I can right click the VM, I can actually move, and I've got a couple of choices. Firstly, I can move the VM and its storage, and that's what's known as a shared nothing live migration. Alternatively, I can just move the storage, so I can leave the VM running on Hyper-V01 but move its disk maybe from one underlying LUN to another. Now I'm not going to show that on this occasion. I'm going to focus on this shared nothing live migration, which is actually going to move the state and the storage in one go. So I'm going to go Move, I'm going to go Next, and I'm going to choose where I'm going to send this virtual machine to. And in this case, I'm going to choose another Hyper-V 2012 R2 host, and that's Hyper-V 05. I'm going to go OK and go Next, and this is going to say, okay, what do you want to move? Do you want to move all the data to a single place? Do you want to spread the data out? So maybe you've got multiple virtual disks attached to this VM and you want to put one on a different LUN from another, or do you just want to leave the virtual machine storage where it is and just move the virtual machine state? That means essentially that the virtual machine's disk must be on shared storage between the target host and the source host. But I'm going to move everything between two standalone hosts with no shared storage right now. So it's going to move 9 gig, it's going to move the running state of the VM, so I'm going to go browse, and this is searching on Hyper-V 5, so the target node. I'm going to choose VMs, and I'm just going to go select, and that's going to pop it on the V drive. We're going to go next, and we're going to go, you see it's going to use compression for the state of the running virtual machine, and we'll go finish. And that particular migration is going to kick off. Now that's going to take a few minutes to move 9 gig of data across our network, so we're not going to hang around for that to finish. But what we've seen in this very brief demonstration is a look at simultaneous live migration using the cluster, using standard live migration, but looked at some of the capabilities and some of the new performance options like compression and SMB, where we turn that on at the Hyper-V settings point. And then we've also looked at initiating and kicking off a shared nothing live migration, which is going to move the running state and the memory, so the memory and the storage of that virtual machine from physical server to physical server. That's standalone, nothing but an Ethernet cable connects these two with no downtime to the virtual machine. So complete flexibility for the IT administrator to move workloads around flexibly, and now with added performance benefits through compression or live migration over SMB. And with that, we'll go back to the slides. Welcome back. Hopefully you found that interesting. Hopefully you found it useful. It's certainly cool technology, seeing those virtual machines ping around and the impact of our new technology can have on those virtual workloads, moving them around quickly, efficiently, with no downtime, which is great. But as I mentioned earlier, when we introduce a new version of Hyper-V or the virtualization platform or Windows Server, the natural pain point that customers typically think about is upgrade. How do I get from where I am, where I've got a significant investment in time and effort and my workloads are running and being used by the business, to there, which is enticing and it's interesting and there's cool capabilities and I want to get there? How can I do that? In previous versions of Windows Server and Hyper-V, you can get there, but there's a bit of downtime. With Windows Server 2012 R2, with the live virtual machine migration upgrade capability, we can help you move your virtual machines from physical host to physical host, from cluster to cluster, with no downtime. So you can see the diagrams animating. We're moving virtual machines from a 2012 host to a 2012 R2 host. Then we're upgrading the 2012 to a 2012 R2 machine, and then we're balancing virtual machines around the network, around the infrastructure as we go. So we've got the flexibility to reiterate. We've got an existing cluster. We'll run through that animation again just to reiterate one more time. 2012 cluster. 3 nodes, all running 2012, 2 VMs on each. It's a big infrastructure, mission critical. We move VMs, we live migrate them from 2012 to 2012 R2. We upgrade that host to 2012 R2. We move the VMs back. They're not part of the same cluster now. They're a 1 and a 2 node cluster. Now they're a 2 and a 1 node cluster. We move the VMs, we upgrade the host, and then we're done. We've moved from 3 2012 nodes to 3 2012 R2 nodes. You could do this with standalone nodes as well. Stand up a separate server with 2012 R2, move the VMs from 2012 to 2012 R2. Jobs are good one. You're easy peasy, no problems, in the box, seamless, effective migration from one platform to another. But it's one way. It's not 2012 to 2012 R2 and back, it's 2012 to 2012 R2. The flexibility this gives you through the GUI, through PowerShell, if you're running an SMB share as your storage repository for your virtual machines, it gets even easier because you're not moving storage. Think about it. You've got your 2012 hosts connected to the shared storage, SMB share. When you upgrade them, your 2012 R2 hosts are also pointing at the same share, so that you can move the virtual machines even more flexibly without moving the disks. So it's an even faster process. We don't need to change the storage location. Complete flexibility, no VM downtime, really brings an important step forward in people embracing the newer features and capabilities without disruption to the business. So very, very important. But the final area of this flexibility is around networking, and specifically network virtualization. Because what we want to help customers achieve is a way of deploying networks, deploying an infrastructure without worrying about VLANs. But they still want to isolate traffic. They still want to isolate those certain customers, certain business units, certain virtual machines. And to do that, we use network virtualization. But what it enables us to do is seamlessly migrate virtual machines into this environment. Think about a service provider, for instance. You've got an environment, you're a service provider, you've built an infrastructure, you've got a certain IP addressing scheme, and you bring on board a customer. The customer wants to run their infrastructure on your premises. Do you want to have the conversation around re-IP addressing that entire customer's infrastructure to fit with your physical and network configuration? And the answer is no. But by using network virtualization, we can create a representation of that customer's infrastructure, bring in their stuff, and they don't need to re-IP address any of their stuff. They can still communicate, they've still got the same setup, their applications still work. It's a seamless integration. And it means when we're moving virtual machines between sites, because the whole network is virtualized across the fabric, it means that the virtual machine can move anywhere and the virtualized network will follow it because we've got that common virtualized fabric. It's really powerful. But let's look at some of the key concepts. In the physical world, we've got our physical hosts. These physical hosts have what are known as provider addresses. These are IP addresses that identify the physical host where the virtual machines and networks will run. So each host may have one or more than one provider address, but that's in the physical world. We then have VM networks. In our diagram, blue and red are both VM networks. They're two separate VM networks. They could be Contoso and Fabricam. In this case, they're blue and red. They could be customers within a multi-tenanted environment. And within there, you've got a number of virtual machines for each customer or each VM network. These are customer addresses. The customer IP addresses are what is inside the virtual machine, the guest OS IP address, if you will. Notice, in this environment, blue and red, they've got identical virtual networks with identical IP addresses for their VMs. But there's no VLANs. So how do these VMs not conflict? How does something not pop up on some monitoring tool that says, hang on, you've got two VMs on your network or two OSs on your network that have both got 10.10.10.10. What are you doing? And that's where network virtualization comes in. And network virtualization uses this policy table to maintain the relationship between the network, which is called blue or red in this case, with a virtual subnet ID, so a unique identifier that's exposed through our virtual machine management tools, Virtual Machine Manager as an example. But to us, for the simplicity of discussion, we'll call them blue and red. You'll see that each VM, it knows in this policy table the VM's IP address, what host it's running on through the provider address, and what blue network or red network it's on. So you'll notice, as we said before, there are two VMs, or multiple VMs that are on the same host provider address, and they've got the same customer address. So how do they not conflict? Well, network virtualization on the Hyper-V platform uses something called NVGRE. Network Virtualization Generic Root Encapsulation. That's a mouthful, but it's also an encapsulation and tunneling protocol that enables us to encapsulate regular packets on the network and to effectively transfer them around the network on the physical fabric. It's a standard that's proposed not just by Microsoft, but our partners at Intel, Arista Networks, HP, Dell, Emulex, and others to help us standardize and improve the software-defined networking portfolio that is out there, the software-defined networking platform that we in Microsoft are implementing as network virtualization. VM traffic within the same virtual subnet is routable over different physical subnets. So let me explain that a bit more. We've got a physical infrastructure here, two hosts. Notice those two hosts are on different subnets, as indicated by the arrow and the different subnets term. One's on the 192.168.2 network, one's on the 192.168.5 network. But as long as they are routable, so they can communicate at the physical layer, anything we put on top with network virtualization can also communicate. So when we create a virtual network and put a couple of VMs on those networks, on that network, because those VMs are part of Blue Network, it doesn't matter where they sit in the physical infrastructure, they can still communicate. So I could move 10.10.10.11 VM, the one on the right, to another host that's on a different subnet. But as long as that host can communicate with these two hosts, it doesn't matter. That's what we were meaning before by complete flexibility, VM migration. When the VM sends its packet, the VM thinks it's just communicating as a normal Windows OS would. So it constructs a packet that consists of the source and destination MAC address, the source and destination IP address, and it sends it on the network. But Hyper-V intercepts that, wrappers it with this generic root encapsulation, and that's how it traverses the physical network in this encapsulated packet. And we'll look at that now in a bit more detail. So we've got this packet flow. On the left-hand side, we have a Hyper-V host, 192.168.2.10, as we saw before. On the right-hand side, we've got 192.168.5.12, two hosts. We've got Blue VM1, Blue VM2, and they want to communicate. But they've never met. They've never talked to each other. They have to do this for the first time. A bit awkward, but here we go. It wants to send a packet from Blue 1 to Blue 2. So what happens? What does a normal Windows OS do? It sends out an ARP request and says, help, I can't find this target that I'm looking for. Where is 10.10.10.11? That's what I'm looking for, I know that. Blue sends an ARP packet to locate 10.10.10.11. It sends it out of its virtual network adapter into the Hyper-V virtual switch that we talked about earlier on. Hyper-V switch broadcasts that on the same customer network, because there might be other VMs in the Blue network that are on this same host. So rather than go out to the physical network, why not just check if it's actually on this host first within the Blue network? And if it is, great, we've saved ourselves a bit of effort. But it's not in this case. So the Hyper-V switch then broadcasts that ARP to the rest of the network, but it gets intercepted. It's not broadcast on the physical network. It doesn't get that far. The network virtualization filter checks its policy table, that one we discussed earlier, and checks just where the hell this VM is and its IP address, its MAC address, all of that kind of stuff. What's going on? Where is it? Okay, if I've not got that information, Hyper-V will talk to VMM, Virtual Machine Manager, and update its table, its policy table, and then provide that information. This sounds like it takes a long time, but it's instantaneous effectively. We then provide that information in the form of the relevant MAC address and information it needs back to Blue 1. So now it knows, okay, I know where 10.10.11 is. Great, let's send my packet. So Blue 1 constructs its packet, and the packet consists of the source and destination MAC and the source and destination IP address. But remember, it has no idea about network virtualization. It just wants to send a packet to Blue 2, which it has no idea where it is really in the physical world, but it knows how to get to it from a network perspective. Hyper-V switch attaches the network ID, the virtual subnet ID, the Blue network in our case, and then sends it on through the rest of the switch. The network virtualization filter then attaches the GRE stuff. It wraps it in a packet and sends it on the physical network. So it knows that it needs to traverse from 192.168.2.10 with the source MAC to 192.168.5.12 destination MAC. So it knows how to get from physical to physical. Once it gets to the target physical host, the reverse happens. Strips off the GRE, finds the correct VM network, the Blue network, and then pushes the packet through to Blue 2. And that's how we communicate in network virtualization. So extremely flexible, easy to deploy through Virtual Machine Manager. Creating these virtual networks is incredibly streamlined and simplified, but that's the process of the packet flow. And in the networking MVA course in Windows Server 2012 R2, you'll learn even more about how some of this stuff is deployed and managed effectively as well. So I urge you to check that out. But how do VMs communicate with the outside world? If I'm in a virtualized network, a VM network, I can communicate with other VMs, great, no problem. But how do I communicate with a laptop of a user, another physical server that's not part of this Hyper-V infrastructure, or something on another site? I need some kind of translation mechanism to translate network virtualized traffic to non-network virtualized traffic and vice versa. And that's where the gateway comes in. This multi-tenanted, production-ready, scalable site-to-site VPN gateway that ships within Windows Server 2012 R2 provides that functionality. So it enables you to deploy a multi-tenanted virtual gateway as a VM into the infrastructure, and it handles that translation between network vert traffic and non-network vert traffic. So the encapsulation, de-encapsulation we talked about before. It's incredibly intelligent, it's flexible, it's easy to deploy, and it enables you to have that scalable middle ground between virtualized network, non-virtualized network, and between your site, and in the example of the diagram, a service provider, for instance, so that you can establish that secure connectivity, join together all of those sites, and move VMs around flexibly between those sites. Remember, network virtualization helps us to simplify the network, move virtual workloads around, and communicate effectively. In 2012 Hyper-V, this gateway didn't exist in the box. Partners provided additional solutions built into switches, hardware appliances, and so on. Now in 2012 R2, it ships in box, and partners are innovating, providing additional capability and built into switches and appliances and so on. So hopefully that gives you an idea of just what's going on in the network virtualization world. It's incredibly exciting. There's new capabilities. There's a whole host of cool stuff that we can innovate in and enable a solution that enables seamless transition of VMs, flexible network management, and true software-defined networking. And I urge you, as you go forward, evaluate. Start deploying these virtualized networks. Start building out the Hyper-V infrastructure. Move VMs around. Look at investing in the RDMA cards. Look at what we've got within the environment and within our partner ecosystem that's enabling you to migrate workloads faster, offload certain tasks to the hardware. Evaluate Windows Server 2012 R2 and the Hyper-V capabilities we've discussed in this particular part 2. Get trained. Check out the rest of the parts. If you missed part 1, go and check it out. We've got more parts coming up that will help you understand our high availability, our resiliency scenarios, and some of the other innovation we're building into the platform. And there's a whole host of other MVA courses that focus on System Center, other Windows Server capabilities outside of virtualization like networking, storage, and so on. And get certified. The courses, check out the courses that are appropriate for Windows Server in your geography, and get certified through the exam process as well. It's very valuable to you, your employer, your customers if you're a partner. So check it all out. I urge you to have a look online at all of those key resources that are in the deck. But thank you for sticking with me. Hopefully you found that content useful. It's been a pleasure to talk to you, and hopefully we'll see you in the next part where we'll look at some of the high availability and resiliency capabilities. Thanks very much.